Hey everyone, this is the first video in a series of videos that is going to help us understand more about the computer from the very basic. We're talking electricity up to how programs run. That's how a program like C is going to execute instructions up to how the electricity is going to work. So before we get started, we need to understand electricity. So the topic today is going to be electricity. So what's electricity? Basically, electricity is made through the movement of electrons. With my own words, I'm gonna say from a region of high concentration of negative ions to a region of low concentration of these electrons. In this case, this is a positive ion. But before we even try to understand what this means, we need to understand the an atom, what an atom is. So I guess, let me see. I think an atom is the smallest building block of matter. Let's just call it that. And an atom is made up of an atom is made up of protons, neutrons, and electrons. Let's look up an atom, and as we can see, okay, let's see. We can see here is a list of pictures of an atom. As we can see, an atom usually is made up of this center part, which is called the nucleus. The nucleus holds the protons. I guess the red ones are protons which are positively charged. And we also have these other ones. These are neutrons. They don't carry any charge. Okay? And this whole thing is called the nucleus. And other than that, we also have electrons as part of an atom. They are the outer shell. I think over here they're being referred to as an electron cloud. But what we know about electrons, they're negatively charged, and they usually surround the nucleus, or rather the protons, as we can see over here. Okay, and now this structure kind of looks, if you want to remember, it kind of looks like the solar system, whereby we have the sun at the center, probably the sun at the center, which forms the nucleus, and the planets surrounding, which are these rings of electrons forming the like similar to the solar system. Okay, and so the structure is usually this way. We have the nucleus, and inside the nucleus we have the protons, let's say the protons, and the neutrons. The neutrons, these don't carry any charge. And around it we have now the rings. These rings, you have a couple of rings whereby the electrons attach themselves to. Okay. And if an atom has a lot of has more electrons than protons, we call that atom negative ion. But if we have an atom which has more protons than neutrons, that's a positive ion. And usually we know that from magnetism, we know that for a negative terminal and a positive terminal, negative and positive terminals attract. Negative and negative terminals repel, and positive terminals also repel. Okay, so if we have another, let's go to another page. Let's say we have established that if an atom is positively charged, is a positive ion, and if an atom is negatively charged, we call it a negative ion. So and we can have this. We can have electrons flowing from. If these are packed, we can have electrons flow from here, from where they're highly concentrated to where there is low concentration of electrons. Okay, and this movement is what causes electricity, right? And so to understand it better, we can look at the structure of a battery. So a battery is a good design. So let's see a battery. A battery is usually made up of the positive terminal and the negative terminal. Okay, so a battery is a good design of a device that efficiently stores the potential difference and is able to push electrons from a region of high concentration to a region of low concentration. So we won't look into details how a battery works, but essentially the negative side of a battery, usually through I think it's what do you call it? Chemical reactions, usually produces a lot of electrons. So we have electron, 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 electron. And if electrons are packed, they want to move. The energy, they have potential energy. They have energy in them, and they need to move. And they need to move from a region of this high concentration of electrons to a region of low concentration of electrons. So in order to allow them to move, usually we need to provide a wire. So we provide a wire. This is a medium of transfer. In this case, I'm gonna use this wire. And if this wire, okay, let's say we have a break over here, and we have probably a switch. So if this switch is closed, that means that electrons are going to flow through this wire from this region of high concentration of electrons to a region of low concentration of electrons. Okay. And now the result is going to be, since there is a greater push over here, the electrons are going to be pushed through this medium to the positive side, where they are being kind of, let's say, being attracted. Okay. And we can take advantage of this and use something like, if we, instead of a switch, we placed something like a bulb. Let's put something over here and call it a bulb. Yes. So if we have a bulb over here, usually a bulb is going to produce light. In this case, these electrons that are going to pass through the bulb, for I think it's a fluorescent kind of bulb. We usually have a filament, and this filament is usually tiny and has some resistance. And as we understand, electrons are trying to move from this region of high concentration to this region of low concentration, but we have a bulb that's forming a barrier in between over here. So in the case of a bulb, we'll have these electrons that are moving through. They are going to find some in the filament part of this bulb. We have positive ions, and since the positive ions usually attract these electrons that carry charge, or rather carry energy, they're going to knock each other inside the bulb, and they are going to excite the positive ions, and the bombardment, the movement of these positive ions, they are going to knock each other, and hence somehow they are going to produce light, and also they're going to produce heat as a byproduct. And yeah, that's how a bulb is able to produce light using electricity movement, by utilizing the movement of electrons. And that cycle of electrons, if electrons come out from the bulb and they move to the positive side, they are pulled back and then sent back through the negative side, and that cycle is what causes electricity, that movement. The fact that the positive side has less of electrons and the negative side has more of these positive ions, these negative ions, and that difference is called the potential difference, or rather the voltage. If the voltage is high, that means that the rate at which this movement happens of electrons from the negative side to the positive side is a lot. And if this, by using the bulb, that means that the this energy gets used up in a cycle, and the final result we have that we notice that the voltage, like the battery itself, is not able to pump more electrons through the circuit. So yeah, that's basically the structure. In short, in simple terms, in summary, this is going to be movement of electrons from electricity is made through the movement of electrons from a region of high concentration of electrons, which is this here, to this region which has low concentration. If you're able to move electrons there, they produce some tiny electrical energy, and that's what we're able to utilize. I think that's the lesson for today, and we'll see you in the next video.